So today we are going to talk about structural equation modeling, a modern technique to analyzing complex relationships between or among variables. So as a beginner, just like me, who is not a statistician, you ask what is SEM or what is structural equation modeling. Structural equation modeling is a statistical method that we use to analyze complex relationships. It combines elements of factor analysis and multiple regression, which allows the researchers to test hypotheses about relationship among observed variables and latent variables. So when we say in SEM, when we say observed variables, it means that they are variables you can measure directly. Let's say marital status. You have something we call, let's say maybe, let's just take the marital status. If I ask you what is your marital status, you only say I'm either married, single, cohabiting, or divorced, or widowed. So you can measure it directly. But when we say latent variables, we have some variables or some particular traits that you cannot measure. You need so many indicators to measure that. So let's say like intelligence. You can't just ask a question, are you intelligent? Then say yes, then you come out saying that this person has intelligence. You need to provide so many questions for the person to answer, which will now take a composite score. From there, you'll be able to identify whether someone is having high intelligence or low intelligence. So anything you cannot measure directly, but you need a set of questions to measure a particular dimension, or let's say trait, then it means that you are dealing with a latent variable. So as a new beginner, or let's say as a beginner to learning structural equation modeling, you may ask, why do you use SEM, or why is it important for me to learn SEM? SEM allows you to analyze direct, indirect, and total effect between variables. It helps you to find out the relationship between, let's say you want to find the relationship between weight and height. This is direct, but now you want to find out whether something influences that relationship. So let's take another scenario. You say that work engagement has a positive influence on job satisfaction. So now you ask yourself, what of if there is stress? What of if there is burnout? What of if there is lack of support? So it means that you want to find out whether lack of support will have an influence, whether positively or negatively, on the relationship between these two variables, which is work engagement and job satisfaction. And that means that you are dealing with indirect effect. So now, SEM also helps you to analyze, SEM handles latent variables, as I said earlier, intelligence, satisfaction, and by linking them to indicators, measurable items, that is a set of questions you are asking in order to determine their intelligence or satisfaction. So throughout this procedure, it provides a visual way to understand complex models involving multiple relationships. SEM is widely used in fields like psychology, healthcare, economics, and education. So what are the key components of SEM? 1. Observed variables. These are variables you can measure directly. As I said earlier, latent variables. Underlying concepts that cannot be directly measured. Let's take depression and job satisfaction. You see that you cannot measure this directly, so you have to use what? A latent variable for that. So paths are about the relationship between variables, and this is normally represented in, that's why we said that there's a visual representation of your models. So throughout the process, if you want to find out any causal relationship between two or more, it means that you are supposed to use arrows for that. So that's why they are saying path. The relationship between variables represented with arrows in diagrams. So when you have a single-headed arrow, it means that you are talking about, or you are trying to find out a regression or causal relationship. But double-headed arrows will help show covariances or correlation. This applies for all SEM softwares you are using, whether you are using Amos, Lizera, you are using M+, you are using, let's say, Jamovi, you are using JASP, you are using Smart PLS, and any other. These are the same when you are modeling. So we also have the next one, which is the measurement model. It helps define how latent variables are measured by observed indicators, and this is normally done using SAFe. You are trying to see how well these your indicators measure the underlying construct. That's why we talk about the factor loadings and all that. And the structure model specifies relationship among latent and observed variables. That is when you try to find out the relationship between so many variables. So with SEM, it allows you to access some measurement model as well as perform a structural modeling. So it's something like you try to find out when you build a SEM model, it means that whilst you are checking to see whether the indicators or items measure the underlying construct, you are also trying to find out the relationship between variables. So for instance, let me give you a scenario. We have an instance where you want to find out whether life satisfaction is your dependent variable, career calling is your independent variable. So in SEM, they have names. When we get there, I'll explain it to you. So you want to find out whether career calling influences life satisfaction. However, you want to find out whether academic motivation also partially or fully mediate the relationship between these two. So when you build the SEM model, you're able to check for the loading to see whether the indicators are actually measuring the underlying construct, which is life satisfaction, career calling, and academic motivation. Whilst we are also trying to find a relationship between these two. So you don't do them separately. They are all done concurrently and you're able to see your output. So now, the next heading is endogenous and exogenous variables. In structural equation modeling, an exogenous variable is termed as independent variable or predictors in the SEM model. So any independent variable you know, when you put them in your SEM model or your structural equation model, it means that they now become exogenous variables. So when you see exogenous variables, it's the same as independent variable or predictor or explanatory variable. When we say endogenous variables, then here we are talking about the dependent variables or outcome variable. So that's just the difference. In SEM, an independent variable is an exogenous variable, and in endogenous variable, which is in SEM, when you come to the old method of analysis, which is like regression, correlation, because SEM is modern, it means that you are dealing with a dependent variable. That's just the difference. So in SEM, endogenous and exogenous variables help define the flow of relationships, with exogenous acting as a starting point and endogenous represent the outcome within the system.